We're back. Hello, everybody. So, just closing down things we have here. I have a web page for you. So, if you guys want to play around with this thing, and clearly my screen doesn't want me to maximize this, it's a web page called regex101.com. Pushed the enter too early. Let's remove this. Let's zoom in so you can get to see around what's going on, and it's actually quite impossible to see because it's zoomed in too much. Anyway, so if you don't want to play around with your advanced text editor and want to keep your Notepad or whatever text editor you like to write your Python code in, you can still do that, but you can play around with regular expressions in your good old kind of web browser to see if a regular expression does what you wanted to do. So if you say def hello colon and hey, I want to match, no, sorry, the other way around. If you have a function and it's like do stuff, and then you want to match your regular expression and you want to capture the def part, and then you want to do anything up to colon and then include colon. Well, colon needs to be escaped, doesn't it? No, it does not. Oh, sorry, I need to have more of them. One or more. So here we have an example of matching the part of the header of a function file, which I can imagine will pop up in your assignment 5. So we're kind of playing around like, hey, how do I do that? Here you have a good way of doing it. It is color-coded, so you get all the pretty colors. And we all love the pretty colors, so that's nice. So regex101.com gives you a way of kind of showing what's going on. So right now, I was going to show you some practical example of where regex kind of pops up in my life. Problem is that I am a consultant, currently working with kind of clients that don't really like that I talk too much about the work that we do. But I sit down at the Radiumhospitalet and we do kind of gene sequencing and kind of classification. We did a talk on that in this class last year on classification. Will you be doing that this year as well? Maybe. So you maybe get kind of a little dip into just a generalized thought about that. But I can't talk too much about that simply because I might say something wrong. But I'm going to try to give you at least some examples of something that feels familiar, that still kind of falls in the domain of regular expression. I'm going to give you 2 examples of that. First, I'm going to show you where regular expression shows up in the programming sense. So for this talk in specific, I made some new slides for it and said that, hey, I want to use my editor as part of it. So I just made a bunch of Python scripts. So if we just do an ls of the folder py, this is all the slides that we've gone through. We started on the front page and we iterated kind of through them. I labeled them alphabetically so I can just don't have to think about ordering, just to make things simple. And then I set a .py at the end of them simply because, hey, you know, these files are valid Python scripts. I wanted to run them so you can see what's going on each time I did each of the slides. But because kind of the way kind of Simon does it, it's like by the end of this lecture, you should have something that you can print out or have on your computer. Then obviously you can do the same thing. I could have just given you that and you will have access to all of these slides. That's not a problem. But maybe we should make some slides as well, as in your PDF style type of slides. And I did, as if you remember from the beginning of the kind of last week, we had these. And these are basically the same thing. They're colorized, and for some reason I can't go too fast, but they're colorized to have syntax highlighting, which is nice, which is something that you're learning because, hey, it is the core part of assignment 5. So this is kind of just a choice of color thing. So how did I do that? How did I go from your general set of Python script into slides that looks like this? Probably if you look hard enough on the internet, you will find a tool if you're lucky. If you're not, you're out of luck, or you need to build something yourself. And since we're programmers, clearly we should do this ourselves. So this is my little tale of how I actually built these type of slides. So simple tools for converting scripts or code into colorized type of LaTeX code. I would say the simplest part is just kind of searching on Google and then say, what is the first hit I get that has Stack Overflow in the URL? You click on that and it's like, yes, I found something. And what I found was Pigmentize. Pigmentize is a kind of sub-module that I see here and there, but never really thought about what it does. But Pigmentize is one of those things that automatically converts things from one format to another. And so I use my homebrew or my apt-get or, yeah, you know, Pigmentize. And it gives you, well, I can't really kind of run it there. I need to put a -h. And then it gives you kind of an explanation of what it does and everything like that. Looking through it, working a little bit with it. And obviously, since this is in 3331, if you're given a tool, read the manual yourself, try to figure out why it works, and try to solve your task at hand. So I'm going to cheat a little bit and just do, let's see, there we go. This is what I ended up doing. So if everybody can see the bottom line here, I do a pigmentized, and I say that, hey, I want the format that I'm pigmentizing to become LaTeX. I want to do the full conversion. The source file is going to be py/a1frontpage.py, and it recognizes that as a Python file. And my out file should be test/a1 frontpage.tech. We run it, it does its thing. In fact, it doesn't, but as a point of reference, it would. So we can go into a1.tech, and what it produces is kind of messy. So, but if you kind of just look at it, it contains basically the code that we need, but it's mostly just parts that is not that interesting, but actually this is not the right code. So the right code is a little more than that. Why did my Pigmentize fail? Something went wrong here. Okay, so the only thing I'm going to kind of show you. So this part is the header of the file, which was missing because I removed it. And I'm going to show you why I did that. So it gets really messy. So basically, this is your part of the LaTeX file that tells what should be colored what. It has all the color codes. So if you see X color or text color, it contains 0.67, 0.13, 1.0. It basically defines what the color for the different components are. And when you kind of go down into the document, it has made this verbatim class and then inserts the color where it's needed. It's messy, but you're not going to touch it directly yourself. And it's on top of every file that I made like this. So basically what I did is that I took one of those files. In this case, I wasn't able to do it right away. I'm going to show you that I am able to do it. And I just put it into a preamble.tech. Now, we're going to look at a file called convert, which is where we're getting to. Why this is relevant in the case of regular expression is that I used regular expression for turning your basic type of LaTeX documents into a Beamer class. So you learn the basic of LaTeX. You start with begin document, you end with end document, and you have something in your preamble and put everything together. The thing is, though, is that when you do slides, then you have the same thing, except that you do a little bit different in your preamble. You say things like include Beamer or document class Beamer instead of document class article. And the second thing you do is that to kind of split slides from each other, you have something called begin slide and end slide. So the simplest thing to do to convert these LaTeX documents that I created with Pigmentize into your Beamer class is just to extract the content and then kind of slap begin slide and end slide at the end. As a begin slide at the beginning and an end slide at the end. So this is what I did in this script. So let's go through it by kind of step by step. So first thing I do is that I just remove slides. Don't ignore that part. So everything is placed in the folder Pi. So I just do a glob. I'm not sure if you're familiar with it, but it's basically a clone, a Python's version of ls. So if you do ls pi/star.py, it basically reads all the file names that ends with pi in the folder pi. A lot of pi. So I take the base name out. I remove the extension .py, clearly. And then I say, hey, I want to be converting that format just to give us a little bit output. And then I run the Pigmentize command. Basically the same thing I did, but this is the correct command. And I say pigmentize-f latex-o full pi/ and then filename.py and tesh filename.tesh. That's why I removed the .py, because I want to convert it into a tesh. So I want to be able to add the extension. Note that I'm using a different format than you are aware of. You know that when you're going to do interpolation with a percentage, I'm using the format command. I'm not sure if you're familiar with it, but it's basically the same thing. Instead of doing %s, I'm just saying that, hey, I want to match kind of curly parentheses. It's the Python 3 way of doing it. You're familiar? OK, cool. Then I don't need to talk about that. Then I open it, and here comes the cool part. I extract out the part that I'm interested in, because it has a preamble, it has a begin document and an end document. I'm not really care about that. I only care about the core content that I want to put on my slide. So I look for my regular expression, and you can see it on line 8. Remember that slashes has a specific meaning, so I need to cancel it if I'm looking for kind of a literal slash character. So // begin, and then a literal curly parenthesis. I don't want it to be kind of a custom quantifier. So / curly start. I'm looking for document curly end. Then I'm looking for any type of content. In this case, I'm looking for either any character or kind of the new line character. And that's kind of the caveat that comes with the any character, the dot, is that it doesn't match new line. It's just kind of how it's designed. Everything is just the way it's supposed to be, that your /n is your delimiter no matter what. So to avoid that, I made an OR group. I could have done that with a custom character class. It doesn't matter. I just threw it together like this. I'm interested in 0 or more, and I want to be non-greedy. And we're not having the problem with the moo ha 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 heh problems that we had in last lecture, simply because beginning document and end documents are so specific that it clearly, it's not going to match something that we don't want it to match, because how could it? Okay, and then after I'm done with that, the only thing I do is that I open the file again and write it to disk. And I'm making an entry into a file called slides.tesh, which is basically, we want to put all the slides together. So what I do is that I want to make a frame and kind of shrink it 20%, input the tesh file that I've just created, so put it in the file name, and end frame. So we get all of this kind of in the same file. And this is the reason why I deleted at the top. If I run this code many times, then I'm basically appending. If you see there, I'm using the append command here, which means that I'm adding it to the file as it is, as in I'm adding it, so I'm not deleting anything. So it's a good idea to just, if it exists, delete it. Okay? Running the code, whoops, a daisy. And it's a little bit slow, but it does what it needs. It extracts the document content, adding the entry to slide.tesh, and then converting each of them one after one. And I did that with regular expression, and that's clearly the obvious way of doing it. I could have done it with string manipulation, but it would require a lot more of me. I couldn't be able to write a code snippet and 36 lines of code in total, including white space and comments and print statements and stuff like that, and get the same output as this. Now, a little bit slow, clearly, simply because it's doing a lot of stuff in the background. I don't really care because it's done now, and now I have all my kind of classes ready together. So, to bring it all together. So first of all, let's take a look at the slides. That's the end part of the code that I wrote. Can we do F1? Nope. Nope, I could not. I'm just trying to do something about the color scheme, since it's a little bit invisible. But this is basically what I did, is say that, hey, I want to have begin frame, I want end frame, and I want to input the file. So just reference it to it. So each of these elements is done, added to the file in the for loop, which kind of references to all the slides that I want to include in everything. And when I go do regular expression.tesh, that one is very, very simple. So I have my basic document class. It's a Beamer class simply because I want to make slides. I have my own little theme called XAL, which is Expert Analytics. I made it at work since we need to profile ourselves. So that's why it's the color scheme it is. And add some kind of basic stuff that I need for doing this. Then I input the preamble, which I manually copied from any of the document classes that I needed because we needed to insert all the colors for the kind of coloring of the code. Also, I needed a frame title, so I made that manually. And lastly, I just say, hey, I want to read the slides. Now, I made the regular expression PNG. If you remember, that's the cartoon I showed in the beginning of the slide, the whole thing. So, hey, why not? Just for fun of it. But this is the interesting part, is that I just do input slide.tesh, and suddenly I've made everything for you. And I made this in like 20 minutes, which is really, really nice. And I made it with regular expression, which is cool, I think. I'm not cool. Anyway, that's part one. That's kind of the day-to-day thing that you're trying to solve the specific problems, and often you get into a situation where it would be nice to have regular expression because you couldn't solve the problem at hand. Now, as I talked about last week, is that regular expression is something that pops on both on the programming side, but also when I do editing of code. So having a regular expression engine available in your editor allows you to do cool stuff, to edit text faster, to kind of do stuff that we could do. So I'm going to show you a code that I wrote part of my PhD, which is not something I should be doing because, as you all know, when we are at the level we are at the master's, we can't really code properly. Or let me rephrase that. I couldn't code properly, so I'm a little bit ashamed. No, it will be fine. So this is wrong. This is the right folder. So I'm going to show you, and please bear in mind that it's not the point that you understand what my code does. It's a big project. It does a lot of things. I do stuff that is related to probability distributions. So this is what my collection of probability distribution does, the front-end wrapper. It's supposed to be available to the user. So it has all the documentation part. And all it does is just, okay, I'm doing my little wrapper thing, I'm adding some property to it, and then I'm just returning it to the user. So this is what happens when we kind of just write code, import, it's called chaospy, so just chaospy.alpha, for example, with a large A, it will return the object, the distribution object. It's not doing any functionality, this is just the front end. When I wrote this, I'm using a documentation style available by, is the NumPy documentation style. So if you go into any type of NumPy or SciPy type of kind of project, typically this is the style of documentation that you want to do. Now, as an example, I imported a lot of code that wasn't mine. So at some point, the documentation style across the project got diluted into not being consistent. And kind of, for the most part, that wasn't a problem. I just changed it as I edited. And then I got to the point where the only thing I haven't changed is the collection of probability distribution. Most of my code was at that time in Google style type of documentation style, while this is in NumPy. So I needed to change it. And changing is not that complicated, as in typically I would, as in going to kind of delete the parameters there, do an args there instead. I would kind of indent this a little bit, and then change this to this, and then I would split line like this. And obviously I can keep on doing this the hard way, doing this step by step. And there you have it. That's the big difference. Also, I would probably indent the whole thing one step up just to kind of follow the Google style perfectly. But it's not complicated, just a little bit. As in, if you're going to change code and refactor code, there are specific tools that allow you to do this. For example, rope in Python is a fantastic thing for doing refactorization, for renaming variables and moving stuff around without it being a problem because it checks things for you. And you will have IDEs that does this for you. But when you're going to do changes to your documentation or change how the functionality of a code, then suddenly you get to that point where it's like, okay, I need to do this by hand. And I did this by hand for this little example, and I could have gone down to the next one, and to the next one, and to the next one, and it is 1,300 lines of code. And then we get to the point where it's like, I'm not going to do this by hand. Or I could, but then I will probably sit 2 to 3 hours. And my boss is not willing to pay me 2 to 3 hours to just rewrite the style of my documentation. That's not going to happen. It's more of a trying to make it consistent type of thing. How can we do it a lot faster? And obviously we can, because we have so many cool tools. And one of those tools is regular expression. So let's start by trying to kind of, well, we need to do a lot of things here. As in, this kind of conversion is not a one-trick pony type of thing to do. Especially the indentation is a little bit complicated, and I can't really show you that using regular expression. I would use other tools for that, but I don't want to make this into a talk about how I use Vim, but instead focus on the things that can be done by most editors, which is the regular expression. So what I'm going to show you is how to change the lock :float dist to become the kind of equivalent command in Google style notation. So first we do a search to match what we're trying to search. For Vim, that's slash, and I want to enable regular expression, so /v. And then we say, okay, the beginning of the kind of word class that we're looking for, or the string that we're looking for, is /w+. So any type of word. Then we have some spaces. It might be one or more. In some cases, there are more. As you can see on the scaling there, there's definitely more than one spaces after the colon. So we're looking for the colon button. Then we're doing space, and then one or more. Because, as I said, this is not consistent. It won't match everything, but it will match about 99%. And if I can do that, then I'm good. And then I'm matching a word character again. I want to match the word. I get float. Then maybe I want to match a comma, space plus, another word character plus. And I want to match 0 or more of this group. So if there are more options for what the parameter should be, I will match them all. Keep in mind that I'm always letting space be one or more, because I don't remember specifically all the 1,300 lines that this file contains. And we can just say enter, and we can just iterate ourselves downwards. And you can see that it indeed matches what I was looking for, which is nice. Now, let's make this into a substitution. Like that. Whoop, I'm missing my S at the beginning. but that doesn't matter because like that. So down left there is my regular expression. I've added the /v to make it. So the first 5 characters is something that is specific to the program, the editor I'm using, but everything from /w plus forward is our regular expression. Now I want to do substitution here. So I definitely want to grab the first word. And I also want to grab, not the space part, but the part that is going into my parenthesis. So changing the style. Also, since we're going to remember, you saw how I do it, I also collapse it with the next line. So what I do is I first of all, space star, in case it has trailing spaces. Then I'm matching for the new line character. Then I do a space star again. I don't use tabs in any of my documents. I just clear them out, so it doesn't. Space is good enough, but if you're trying to be fancy at this, I could have just written /s, and that works the same way. So we can match other types of space characters. And then with 0 more of that, and then we get to the other end of that string substitution. So what do we want to substitute it with? Well, we want to keep part 1. The second part, we want to put in parentheses. So what did I do here? So remember that normal parenthesis has a special meaning in regular expression. That means a group. And you can do match substitution both inside your search string and your replace string. So that means that you're not exempt from using canceling operators for groups. The same does not go for other type of character classes. If you say dot in what you want to replace it with, then obviously it's going to interpret that as I want the actual dot character. You may cancel it if you like, it doesn't care. But sometimes it's kind of logically, it's like, I want to match any type of character class on insertion. I am not actually have a clue what that should be, so regular expression in most cases just assumes that means that that you want a literal type of put in this character. But not for parentheses, because you can do match part, so it has meaning. So in this case, I want to cancel out my slashes for my parentheses because I want a literal parenthesis. I want a space and a colon because colons are cool, and then a space there. And since I grabbed keep in mind that I grabbed more than just the line that I was on, but also grabbed all the way down to the next line, it will remove the new line character that we were so interested in. I'm going to add a /c, and the reason for that is specific to the Vim editor, which means that I want to do this iteratively. I want to see what it matches and help me get through it. And here we go. So it matched the whole line, look, colon, float, dist, new line, more spaces, all the way up to location parameters. And then ask me, do you want to replace /1 with parenthesis /2 colon and a lot of spaces? And prompts me with yes, no, abort, quit, the basics. So if I just write yes, then it did it for me. Substitution. And I can do yes again, and then I can say all. And then I'm done. It didn't perfect do it. Specifically, if you go up in line 1118, it's not code I wrote, but somebody who did a pull request for me from, I think it was the Netherlands, a partner in crime in doing my PhD. So I need to fine tune it and make sure that everything works perfectly. And the reason why it didn't match that there is because it didn't have an optional character, and I could have refined my regular expression to do it. But keep in mind that we're here. We have a lot of line of code. This is a big file wrapping for about, I think it's about 80 different distribution. And I did, in a part of about 10 minutes of just explaining to you, changed 99% of what I needed to do. And my bosses allow me to use 10 minutes to do stuff like this. So this is how my day-to-day goes, that sometimes you hit the wall and find a task that is very repetitive in your text editor. Then tools like this, it's just fantastic for precisionally just changing everything you need and get to the point where it's automated, that you can do If you can do 1, 2, or 3, then you can do all. That's very, very nice. Yeah, that's all I came here to talk about. We have about 10 minutes left of the lecture. So if anybody has any questions to these topics, this would be the time. So seems it not to be. So, okay, thank you very much for your time.
Okay, Jonathan, thank you very much. I just want to announce the next lecture. So in total, this course will have 3 guest lectures. 2 of them you've just seen. Next week, we will have Benjamin R. Kelly from Simula here, talking about Jupyter Notebook. I'm sorry. So Jupyter Notebook is a project. It's a Python project, originally Python project, that allows you to write Python programs in the style that you know maybe from MATLAB or Maple. So it's a dashboard that you can use through your web interface, and you can write Python code in it and execute it live. So in particular, it's the tool that I used for my lectures. And they've now been extending this to not just to work with Python, but also with various other scripting languages. And it's widely used. So if you remember I think it was a few months ago when when scientists discovered these gravitational waves. The way they publicized these results was through a Jupyter Python notebook. So that's how they communicated their results to the public. And so Min is one of the core developers of the Jupyter Python notebook, and he will come here and tell you a little bit about the project, what you can do with it, and yeah. So looking forward to see you next week.